G'day, this is my mill. It's a Saggio UF52. It's a universal mill. Saggio is a Swedish brand, and like a lot of English speakers, I tend to not know terribly much about mills and equipment made in non-English speaking places. And so I came upon this by surprise. I sort of just was looking for a small universal mill and discovered the Saggio brand, had a look around, and this is what I ended up with. So I was asked if I could do a bit of a mill tour, and so I will, but the majority of things you can do with a mill is done with the accessories. So not only will you see the mill, but you'll also see some of the modifications I've made to it, and you'll also see some of the accessories that I use with it. Some of them you've probably seen in other clips, but we'll reintroduce them anyway and we'll go from there. Unfortunately for me, all the instructions here are written in Swedish and I don't speak Swedish, so I've had to learn the hard way. However, this is the speed table, so it can go from 40 RPM up to 1800 RPM. I rarely get up this high, you know, and stick around here somewhere, but it's there. Speed change is done with a combination of this lever, and just down here, and these two levers down here. So 12 speeds, quite nicely spaced. I rarely have a problem. One of the things that might be worth noting here is that next to the speeds I've written in Texter, and so I'm going to have to renew a few of these, but some numbers in brackets, and that's the diameter of cutter for steel, high-speed steel on steel. And I just find that's a very quick and easy way of working out what speed I should be in if I'm a bit unsure. One of the most useful things you can fit to a mill, I believe, is a DRO. This is an eBay DRO, Sinotech, I think. The casting here is curved, and so one of the things I've had to do is actually to mount this and keep everything level. I've actually had to make up a little metal spacer here, which is a wedge shape, just to try and get it so that the swiveling action is, you know, the axis is vertical, and it's not going to sort of try and swing one way or the other. This is the Z scale bracket on the down there out of sight. Runs the indicator up and down. I had to be careful to miss the oil filler and a few things like that, but that works quite nicely. This is the Y scale, and I've got that mounted on the cover for the feed motor. It's got a separate feed motor, this mill, which is sometimes good and sometimes bad. But those two are conventional scales. The front DRO scale here is a little bit different. It's a magnetic strip. And so it's very thin, and this aluminium strip just covers it. The reader head is behind here. It plugs straight into the DRO. It's still got that serial connector, so that's all good. But the reason I went for this was that DRO scales typically are thick, you know, 12, 15 millimeters thick. When the table's right in, it'll get crushed against the column anyway. Because the table swivels, I can also crush it in other ways as well. So I put it on the front here, and then I use the magnetic version to keep it low profile. So that way I've still got access to you know, stops and things down here and all the rest of it. I haven't got my vision impaired. If I had a scale which was, you know, 15 thick and 30 odd deep sort of thing. This is the gear that I use for tramming in my mill head. It's a Starrett 196, I think it is, rear plunger indicator. This is all part of the kit that comes with it, and this one I just made up myself. It's just a thing that I can hold it in a collet chuck and do that. This way over, what's that, 7 inches, so swing 14 inches, I can get down to around about a thou, which gives me you know, very nice tram. But certainly for tramming, I found this is probably the easiest way. It saves having to work out what your twin dials are doing. It means you don't have to have a mirror up to check what's happening. It's a very nice bit of kit and very good for this particular application. There are other things you can use it for too, but this is the main one I get to use it for. I've made a few modifications to the mill. One of them was fitting this vernier scale to the head tilt. Previously it was just a mark, and because of the way the head goes back on when you take it off and put it back on, that mark may not be accurate. So I've got some slots there with some screws, so I can adjust that up to, once I've trammed this in, I can adjust that up, and then with a vernier scale there to tenths of minutes, I can push this thing around to around about where I want it. In this case, it's set at 4 degrees and 40 minutes, because I'm about to cut a gear like that. I can operate this mill in 3 ways. One is vertically with the head here, and I'll show you that in a moment. This is in its horizontal mode with the horizontal arbor, and the table can swivel as well, up to 45 degrees each way for cutting helical gears. So I put a gear tooth cutter in there, dividing head on the end, and then I can swivel that and get the helix angle. You can also do that with the vertical head, but this is just another way of doing it. One thing to watch for if you're looking at a horizontal mill and you think, oh, you beauty, horizontal mill. Some of the earlier production machines were either lever fed or they were power feed, but they'd only feed one way, and that was so you didn't indulge in climb milling. So you'd set it up and it'd only feed one way, so it wouldn't climb mill. So this one will power feed in all 3 axes, but some of the sort of converted production machines, you may find they only feed in one axis, and so that's something to watch for these. One of the reasons I bought this one was that it did feed in all 3 axes, because some of the older horizontal machines I saw, even though they had the vertical head on them, would only feed X, Y, would only feed in X. The Y and the Z still had to be hand cranked, whereas this one will do all 3. This is the other way I use the mill, with the cutter coming out of the horizontal spindle. What this allows me to do is, if I've got something that's very tall, I can get the full X travel plus, well, I can never remember which one it is, but quite a bit of Z. So I could face off something like that. In this particular case, I'm going to set up just to take some ends off things, and it's easier to set it up this way than it is to try and juggle with the vertical head. So that's something that some people forget about what they can do with a horizontal mill, but it is a handy way, and it'll get you out of trouble occasionally. I've never tried it myself. I have heard of people also mounting a workpiece on the horizontal spindle and putting a lathe tool on the bed and using it as basically a large lathe. That'd be possible. It could work. You just have to be careful about how you're doing things with feeds and overhangs and all that sort of thing. But if you had a diameter 300 or 400 disc that you wanted to true the edge up, and it wouldn't fit on your lathe, then yes, you could do that. This is the mill set up with the vertical head in place. It's how I use it most of the time. It's probably the only drawback of this machine, I think, is that this vertical head doesn't have a quill on it. At the same time, I've been told by people that if you have a quill and you machine with the quill right down, you're causing yourself problems in terms of rigidity and accuracy and all that sort of thing, and wear for that matter. So apart from drilling the odd hole, it probably doesn't matter too much. The other thing you'll need for your mill is a good vise. This is a Vertex Angulock style vise. It's only a 4-inch vise, but that's plenty big enough. As these things get bigger, they get far heavier. And so, you put an extra 1 inch or 2 of vice jaw on, and suddenly your weight is increased by 10 kilograms. It's quite extraordinary. But these are good because there's a ball in the back here. The screw pushes a wedge against that, so it pushes that jaw down. And if you've got something where you're milling close to the jaws, I've done it myself, where this jaw is 0.5 millimeter higher than this jaw, and I do a cut across, and suddenly I discover I'm cutting on the vice jaw. So that's something to avoid. This vice has got what's referred to sometimes as a speed handle on it, and I just find this is far easier to
manipulate than the standard handle that comes with a vise. I've still got that here for times when I need to put an extra bit of oomph into it, but for the majority of times this works fine. With a lathe, it's not quite so bad. You know, a couple of chucks and a couple of tools and you're usually away with a lathe. With a mill, you can expect to pay quite a bit for tooling, and the rule of thumb that we use, you buy a second-hand mill and you're going to pay that again probably for tooling once you're all set up. This is an angle plate, or a sine plate sometimes they're called, and it gives you a precise angle. I don't use it often, but it's one of those things that every so often you do use. Other accessories are a dividing head and a rotary table, and they're used reasonably often, and a vise, of course. If I had the choice of a rotary table or a dividing head, I'd probably pick the rotary table to start with. A lot of them can be set up as dividing heads, and they're a little bit more versatile in what you can do. Dividing heads you can get more numbers with, and if you've got a universal mill like this will drive off an end, then a dividing head's worth getting. But as a first accessory after your vise, I'd suggest the rotary table. Then there are dividing heads. There are typically two sorts. This one here is a universal dividing head, and you can tell that because it's got the shaft coming out the back. This one is just a plain dividing head. This is the Ellis that I occasionally work on. These also come in a range of sizes. This is a BS2 size, which I think stands for Brown and Sharp 2. It's a Brown and Sharp probably commonised these things, and so this is a size 2. There's a size 1 and a size 0. The size 0 is probably around about that size. Much easier to lift on and off. The reason I have two of these is that this is small enough I can put that on my rotary table if I need to get a fourth axis arrangement. But this one I have because I cut helical gears, and so by driving through here I can get that rotation type thing with the helical gears, which is handy. These are quite expensive because they're quite heavy too, all up about 50 kilograms. But there's a whole bunch of gears and things that come with this. So unless you're planning on doing helical gears and you've got a mill set up to do it, I would suggest going with the smaller type. This is the other common bit of kit used on milling machines, is a rotary table. This one's an 8-inch rotary table. My rule of thumb is that you want a rotary table as big as you can, but no bigger than the width of your milling table. The reason for that is that if you have it centered on the table and you wind back, if it's bigger than the milling table, then you're going to run into your column or something like that. Whether that's ever going to worry you, another matter, but that's my rule of thumb. The other thing is that these are another bit of kit that gets massively heavier for a slight increase in size. So if you can get away with a 6-inch rotary table or a 4-inch because of what you're doing, you're probably better off doing that than rather than going to a 6 or an 8 or a whatever. This particular type can be fastened down in two ways, either bolted to T-slots with the holes there, in a vertical fashion like so, or bolted down to the T-slots with the loop there. This end needs a strap clamp, but I've made up one of those, and that just sits in there and that will clamp down. So just to save mucking around with strap clamps and spacer blocks and all that sort of thing. The other nice thing about that is that that's the same height as the hold down clamps I use in my vise, so I can take the vise off, put this on, slide them on, and we're all done. If you're one of these people who occasionally needs a larger table than your rotary table, one of the things I suggest is make up a false table like this. This has got 4 pins to locate in the slots. I use some T-slots, T-nuts to bolt down to these recessed holes, but that means that my rotary table is effectively 10 inches. Sometimes that helps. So something to consider rather than going to a bigger table for occasional use, because I can tell you that this is a lot lighter than the increase going from an 8-inch to a 10-inch table. Last thing I'll mention are a few of the other accessories that you may need to get or need to think about getting. Probably the first one, most important one is the clamp kit. And not only will these things allow you to clamp a vise down, but there's all sorts of other things for holding bits and pieces together. I've standardised in my workshop on a 3/8 by 16 stud thread, and so everything, including my custom T-nuts, is set up for that. It's occasionally useful to have something like a 3-jaw chuck to hang on to something. So this is just one that's been fitted with a flange that I can clamp down to the bed. Bit of shim, that's 1/2 millimetre. I work in millimetres on my mill, and this is what I use for setting my Z height. So I'll wind the bed up until that pinches between the cutter and the work, and that way I can say, well, the cutter is now 0.5 of a millimetre off the work face. You need something like that. Guessing doesn't quite work. V-block, handy thing occasionally when you're doing round material on the lathe. On the mill, sorry, so you can put that on the bed, put the round material on top and clamp down on that. 1, 2, 3 blocks, very useful in conjunction with the clamp kit for doing bits and pieces. Angle plates, this is one of my small angle plates. I've also got a larger one, which is about that high for doing various bits and pieces. So as you can see, a lot of accessories that you can get for milling. I've got a few others stashed around the place, but I think we're getting into accessory overload here. So it's easy to see how you can sort of double the cost of your mill purchase with just the accessories that you can get for it. But I hope this has been of interest and shows if people what you can actually do, and some of the things that you may want to get for your mill.